Hi, I'm Andrew, here from OptiLab to demonstrate our 40-kilometer distributed fiber Bragg grading sensing system without the use of any repeaters or amplifiers. OptiLab has three unique interrogator models, including a 1U rack mount, aerospace module, and outdoor unit. These systems are applicable for oil pipeline transport, railways, tunnels, aerospace, and geological events. To accurately monitor the structural health for 40 kilometers of an oil pipeline using distributed FBG sensing, you are faced with a large amount of sensors, lots of data to process, large propagation loss, and sensor location-specific time delay. With a large amount of sensors, the time delay issue becomes more prominent. To overcome these issues, OptiLab's FSI utilizes advanced digital signal processing (DSP) technology for high speed and high resolution detection. The FSI's DSP enables FFT, which reduces data traffic and post-data processing. In addition, our unique design utilizes high dynamic range and channel-specific delay time compensation. The distributed sensing system will have a total of 4 OptiLab rack mount FBG sensor interrogators, FSIs, each with 18 channels running at 1 kHz. Now if we look at the diagram of the system, each channel monitors 6 FBGs that cover 0.6 kilometers. Each interrogator covers 10.8 kilometers. The total sensor distribution range is 43.2 kilometers. Interrogator number 4 covers the last 10 kilometers and utilizes a high optical power design. For the demonstration today, we are presenting the last 5 kilometers of the high-powered system. This setup is comprised of 1 FSI rack mount unit, 9 fiber spools ranging from 35 to 40 kilometers in length, 9 FBG test beds. Each test bed has 2 channels of 5 FBGs with 100-meter spacing. 9 channels of the FSI are connected to the test bed using 35 to 40 kilometer fiber spools, while the other 9 channels of the FSI are connected directly to the test bed. All 18 channels are in use with a total of 108 sensors monitored. The system is set up at OptiLab's headquarters in Phoenix, Arizona. Here we have the FSI with 9 of its channels connected to these 35 to 40 kilometer fiber spools that are then connected to these 9 FBG test beds. The other 9 channels of the FSI are connected with yellow fiber directly to the FBG test beds. FBG test bed channel 1 is connected in series with a tunable FBG. The tunable FBG is then also connected in series to an FBG pendulum. To begin, we will enter the time domain section of our software to view the wavelength over time measured by the FSI. As you can see, as I toggle through the channels, all the FBGs within each channel are displayed at their proper wavelengths. Note that FBGs on channel 1 through 9 are post 35 to 40 kilometer fiber spools. If we go back to channel 1, you will notice that there are 2 more FBGs than the standard 5 in all of their channels. This is because a tunable FBG and a FBG pendulum are connected to the FBG test bed on channel 1 in series. Now we zoom to the tunable FBG and FBG pendulum wavelengths by changing the minimum and maximum wavelength on the graph. So if we look at the tunable FBG wavelength 1552 nanometers, when I input a sine wave into the tunable FBG, you can see the sine wave in the wavelength measurement. Now as I change the input of the tunable FBG, you can see the change within the measurement. Now, if we look at the FBG pendulum wavelength 1549 nanometers, when I oscillate the rod of the pendulum, you can see the oscillation within the measurement. Now remember, this is almost an instantaneous change you are seeing when the FSI could be located here in Palo Alto while the sensor is in South San Francisco, 25 miles away. Now if we go to the FFT section of the software and select the proper channel ID and gauge ID for the tunable FBG, when I input a waveform to the tunable FBG, you can see the amplitude over frequency of the waveform. Now if I put in the sweep function into the tunable FBG, you can see the amplitude sweep over the frequency. Now if we change to the proper gauge for the FBG pendulum, you can see as I oscillate the pendulum, the amplitude spikes and the frequency changes. That concludes our demonstration of 40-kilometer distributed FBG sensing with OptiLab. Thank you for watching. For any further questions, please visit us at www.optilab.com.